I'm Tony Sleva, the president of Pressure Transmission Systems. And today's webinar is going to be assessing and reducing the risk of electric power lines igniting wildfires. This is a relatively new topic in the electric utility industry. Electric utilities normally wait for something to happen before they take action. And so wildfires have come up and they've been a problem, and now we're starting to address them. So anyhow, today's webinar, we're going to talk about why understanding wildfire risks are essential. And we're going to dive into the 10 best practices that we can do immediately to reduce wildfire risk. We're focused right now on what I can do to prevent wildfires this wildfire season and next wildfire season. This would be things that are operations and maintenance expenses at the utilities. Capital expenses where you're undergrounding lines and you're doing a bunch of work like that, that's going to take a long time, and that's beyond the scope of what we're looking at here. And then we're going to talk a little bit about the assessments that Prescient can do for you. So if I look at this, the wildfire risk, it's increasing and it's expanding across the US. The summers are growing hotter and drier. And today is an example of that, where I've got excessive heat warnings throughout the whole Pacific Southwest at this point. At this point in June, I'm not accustomed to getting these extreme heat warnings. And it's no longer just an issue for the Pacific Northwest or California. We've had fires in the Pinelands in California. We've had them in Kansas. We've had them in Texas. So there's a lot of wildfires occurring. And we see the insurance companies increasing their rates. This year, we think the rates went up somewhere between 200% and 300% for a lot of electric utilities. They're probably going to go up that much next year too. And the wildfires do present a challenge to grid resilience and reliability. I think it was 2 summers ago now, we had a large amount of wildfires in the Pacific Northwest, and the wildfires put so much debris on the Oregon-California intertie. Now, this is 3 500 kV lines that start in California and they terminate in they start in Oregon, they terminate in California. They're on approximately a 10-mile difference between the right-of-ways, and all 3 of those lines had to be taken out of service at the same time because of debris coming down from wildfires. And we have to make sure that we improve our customer relations so that customers, when a wildfire occurs, they don't immediately assume it started with electric utility, and we have to contact the law firm to see who we can sue. So I'm looking at this, I'm thinking there's 10 things we should do to quickly get ahead of wildfires. The first is to designate a wildfire awareness manager. The second is to establish a baseline, analyze prior year data, document burnable material areas, assess environmental conditions, understand burnable material ignition, understand energy deposition, enhance our operations, patrol lines post-fault, and perform wildfire reviews. These are the 10 topics. We're going to go through each of these topics one at a time. So the wildfire awareness manager, they should be overseeing our wildfire awareness plan. And I'm thinking the wildfire awareness manager shouldn't be a transmission line engineer or distribution line engineer. They should be someone who's focused on the environmental impacts and the wildfire issues. Transmission engineers are good guys. Distribution engineers are good guys, but they have a tendency to focus on the lines. And really, the wildfire awareness manager has to focus on fires. And you're going to focus on impacts and prevention. And you have to have a strategy. You can't wait until after a wildfire occurs, because the news media is going to show up at your door and ask questions. So you should be analyzing prior year's data. You should be requesting funding for projects to reduce the possibility of wildfire ignition. You should be establishing contracts for fault response teams. You should be overseeing wildfire awareness drills, and you should be monitoring environmental conditions. So as the conditions change and they move from moderate to high to extreme, the wildfire awareness manager should be alerting operations and alerting the executive committee to the level of risk that's out there. So the wildfire awareness manager should be a key position at every electric utility that's got the possibility of a wildfire. Establishing a baseline is really important. Uh, we're building distribution lines through wildfire prone areas. People want to build houses in wildfire prone areas. They want to move out of cities to rural areas, and they want distribution lines built out to serve their house. And so we have to understand the risks of distribution lines. And energy production facilities are being built in remote areas. Right now, they're proposing to build a huge offshore wind farm near the California-Oregon border. This would be in Coos Bay, Oregon. It'll be a 6,000 megawatt offshore wind farm. 6,000 megawatts, that's a lot of energy. And we're going to wind up building three 500 kV lines from the Coos Bay area, which is a very remote area, to Portland to sell the energy in Portland, and to Sacramento and San Francisco to sell the energy in California. And these lines are going to be built through wildfire prone areas. They're being built through national forests. And so that's a problem that we really have to understand. And the baseline parameters include the total miles of transmission and distribution lines, and then how many of those lines are in wildfire risk areas. It doesn't do any good to say I have 40,000 miles of distribution lines. The question is, of that 40,000 miles, are 5,000 miles in high risk areas or 1,000 miles in high risk areas? So there are things we want to know. And then another thing we want to know is the number of transmission line and distribution line trip outs that are occurring every year. If I have 1,000 trip outs in a year, and I've got 40,000 miles of line, that's a lot of trip outs. So I should be doing things to reduce the number of trip outs. And then I want to know, how many days do you have high risk wildfire conditions each year? I'm thinking in 2024, we're going to have, in Oregon, where I live, we're probably going to have 8 days that's high risk wildfire conditions. And under high risk wildfire conditions, people are going to be concerned about, well, am I going to turn off power preemptively so that if a tree falls in the line, it definitely doesn't ignite a fire? And these are the type of things you're going to look at as a wildfire awareness manager, and you're establishing a baseline that you can give to your management, and you can give to the news media, and you can give to government regulators, so that everyone understands that you have a good understanding of wildfire risk. And then we have to analyze prior year data. And when I look at prior year data, I'm looking at three classifications: first order, second order, and third order data. The first order is the basis for immediate remedial action. If I have 1,000 faults in a 1 month period, that's like, wow, tremendous amount of things I have to change. So I want to know how many faults are occurring and how many outages are occurring during high risk conditions. And who's evaluating the environmental conditions, the ambient temperature, wind speed, and things like that. And what's the findings of the fault response teams? I don't think utilities have fault response teams today. I think they have to get fault response teams out there to immediately get eyes on a fallen conductor someplace or a fault that occurs someplace. Second order data, this is actions that were taken to reduce the risk of wildfire when you have faulted transmission lines or faulted distribution lines, and the actions that were completed by utility teams in support of risk reduction. Then the third order data is data that's coming in from other utilities. When a wildfire occurs, the news media descends on the local utility, and the local utility launders a lot of information and gives it to the news media. But our subject matter experts at your company can look at that and get through it and say, wow, these things are noteworthy, and maybe it's something we should watch out for, and it's something we should be putting in our hopper of things that we're going to do. We should be documenting burnable material areas everywhere we have them. I'm hoping that everyone's drawings for transmission lines and distribution lines today are electronic. And that means that I can put layers on the drawings, and I could put burnable organic material zones on the drawings. I could put peripheral clearance zones on the drawings. I could put fire stations, staging areas, and other details that the Wildfire Awareness Manager tells me to put on that drawing. So one of the concerns we have is that vegetation management today is focused on trees not contacting the line, and lines not sagging down into trees. When I look at peripheral clearance zones, when I go out and look at the transmission lines in Oregon, for example, in a Tillamook forest, that's a state forest in Oregon, there's a 115 kV line going through the forest. I see trees that are upslope from the transmission line right on the edge of the right of way that are 100 feet tall. If those trees fall down onto a transmission line in a high wind condition, that could ignite a wildfire. And that's something that we want to know about immediately and respond to immediately. And assessing the environmental conditions. As the temperature increases, the probability of wildfire ignition increases. As the humidity decreases, the probability of ignition increases. More days without rain increases the possibility. Sunshine increases the probability, because what happens is I have to get to a basic temperature to ignite a fire. Like if I'm looking at hay, I can ignite hay at 170 degrees C. If the ambient temperature is 50 degrees and the solar radiation on the hay adds another 10 degrees, I've only got a temperature difference of about 100 degrees between the actual temperature of the hay and the ignition temperature of the hay. So I want to look at all these things and make sure I know the risks I'm facing. And dry lightning is an issue in the Pacific Northwest, because when the humidity is really low, it rains, but the rain doesn't make it to the ground. And we refer to that as dry lightning. On the East Coast, when I lived in Pennsylvania, when we had lightning, we had thunderstorms and there was a lot of water coming down. It's not like that on the West Coast. And high winds, they create airborne debris. And once the fire starts, they can really spread the fire quickly. So we start thinking about like understanding burnable organic material. And what's the ignition time of it? Well, it turns out the material scientists gave us two equations. One equation is for thin material. Thin material is something that's less than an 1/8 inch thick. And thick material is something that's more than an 1/8 inch thick. So they're saying the ignition time is really a function of what's the ignition temperature and what's the starting temperature and how much energy have you deposited on the burnable material. And for thin material, the key factors are temperature differences. And I mentioned for hay, it's like ignition temperature is 175. And I start out on a hot day where the temperature of the material is 60 degrees. So I've only got a 100-degree difference. And the heat flux, when I'm talking about heat flux, I'm talking about watt seconds per square inch. This is the same as we're looking at for arc flash. When we do arc flash calculations, we do them in watts per square centimeter. That's because the arc flash concepts were all started by chemical engineers. And when I'm looking at organic material, I'm thinking electrical engineers should be doing it. So electrical engineers should be doing it in watt seconds per square inch. And when I'm looking at thick material, the equations are slightly different and the parameters are different. When I look at thick material, I'm thinking of pine timber. Well, pine timber is going to ignite at about 375 degrees versus 175. The starting temperature is still going to be about 60 degrees. So if I take there's a 300-degree difference for thick material versus a 100-degree difference for thin material. And when you look at the equations are quite similar, but I'm using thermal resistance for thin materials. What we're saying with thin materials is all the heat is deposited on the surface and it doesn't go anywhere else. When I'm looking at thick materials, I'm saying, well, when the energy is deposited on the surface, it can transfer into the material itself. So it looks to me like the ignition time of thin materials is typically an order of magnitude greater than the ignition time of thin materials. And that means when I'm looking for understanding burnable organic material, I focus on what kind of thin materials do I have that could really ignite the fire. And this is what we see when we go camping, right? You always start out with some kind of kindling to start the fire. And then when you get all the kindling burning, you start throwing in your logs and you got a good fire all night. And that's what we're looking at. This is the type of concept that is here, understanding burnable organic material. And when I look at different grasses and different trees and different leaves, I get a range of ignition temperatures. Hay has a really low ignition temperature, like 175 degrees C. So I use hay as the burnable organic material when I'm doing calculations, because that's a good low number. If I were going to testify in court, I would actually find the material that's out there and do all the calculations for the material that's out there. But in general, if I'm just doing wildfire analysis, I'm going to focus on what's some pretty severe conditions. So if you're talking about energy deposition, there's two ways we can release energy from a transmission line or distribution line. The first is arc flash. That's what we wear the arc flash resistant clothing for. And when we're doing switching in a substation someplace. And the energy deposition is just a function of energy released divided by surface area. When I look at the energy released, it's I squared times the resistance of the arc times time. Well, it turns out the resistance of the arc is pretty easy to calculate. Arcs typically have 500 volts per foot. So if you know what the current is, you know what the arc resistance is, and you can calculate the energy that's released as a function of I squared R T. The surface area, we're assuming that we've got a sphere and the energy is all on the surface of the sphere. We don't lose a lot of energy through air. And you notice this at campfires. When you get too hot at a campfire, you back up. And when you're too cold at a campfire, you get closer. And that's the same type of thing we're talking about here. The radius of the sphere is from where the arc is occurring to where the dry vegetation is. When I'm doing calculations like this, I make the assumption that the dry vegetation is 2 feet away from an insulator. And that gives me the maximum energy that I'm transferring and putting on the surface of burnable material. If you don't have anything that's going to burn nearby, if you're 10 feet away, the energy from an arc flash 10 feet away is a lot less than it is at 2 feet away. So then this other thing is, what happens if you get an accidental contact? If a tree falls on the line, once again, it's energy released divided by the surface area. It tells me how many watt seconds per square inch I'm getting on the tree. And that's what I'm focused on. How many watt seconds per square inch? That's the energy that was in the calculation where I was looking at the vegetation ignition. And so I'm looking at this, and typically for something like white pine, we assume that you have 2,000 ohms per foot of tree. So if you have a 40-foot tree fall on a transmission line, that's 40 times 2,000, that's 80,000 ohms. So the current is going to be small, but what happens is when I'm looking at ignition, typically I get an arc associated with current flowing through a tree. And that's going to be in a relatively small area. It's going to be in a 1/4 inch area. So we've done these calculations with I squared R of the tree, and R of the tree is a function of the length of the tree, and we'll use 2,000 ohms per foot. But the surface area is a quarter inch times the length of the tree. So if the length of the tree is 40 feet, uh, 40 feet, and that's only a quarter inch wide. So the surface area is not the whole surface area of the tree, it's just a uh, conduction area through the bark of the tree. So I'm looking at things like this. We're thinking you're going to take all this stuff together and you're going to have standard operating modes, you're going to have balanced operating modes, and you're going to have enhanced operating modes. With the standard operating modes, you're going to have traditional protective relaying and reclosing practices. These are set up so that I optimize my interruption frequencies and my interruption duration and those key indicators that I'm looking at. In balanced operation, I'm saying I'm going to allow miscoordination of some devices. I will allow single shot reclosing, but I'll only allow manual reclosing after a fire watch, patrol the line and determine there's no fire in the area. So if I'm looking at like traditional protective relaying, under standard operation, I might have an instantaneous relay set at 2,400 amps. Under balanced operations, I would reduce the set point of an instantaneous relay from 2,400 amps to 1,800 amps. 1,800 amps can overreach a recloser or something like that, but it won't reach to the end of the line, but it's okay. When I get extreme or high wildfire risks, I'm giving up coordination whatsoever. I'm not going to use automatic reclosing. I'm going to set my instantaneous relays as low as I can so that I got maximum sensitivity. So under traditional, I could set an instantaneous relay at 2,400 amps. When I'm in balanced operation, I give up some coordination and I reset that relay at 1,800 amps. When I'm in enhanced operations, I'm going to reset the relay to 1,200 amps. I don't have any coordination on that line, and I'm not going to allow automatic reclosing because when I'm in enhanced operations, high wildfire risk, I know I've got high temperature. I know I've got low humidity. I've got days without rain. And now I've got high winds that could be blowing trees over. So I'm looking at that and I'm saying, any faults that occur on this time, I'm gonna take it out and let my line go out of service immediately. I'm not going to reclose. I don't care what my performance indicators are. And the assumption is when I'm looking at this is that you've used microprocessor-based relays. And the microprocessor-based relays have setting groups. So setting group 1 would be the traditional relays. Setting group 2 would be the balanced relay settings. Setting group 3 would be the enhanced operations. When I first did this, I looked at microprocessor-based relays and they had 6 setting groups. So I set up 6 setting groups and I had 6 different sets of settings to use. And then I explained to the utility what I was recommending they do. And they explained to me that maybe we should only use 3 setting groups. And that's how we got to 3 setting groups like this. And then we were trying to see how do you name them? And the way balance came up is we're taking a balance between optimizing our performance indicators and reducing our fire risk. Enhanced operation, that just means that we've got a high fire risk at that point. And then patrolling lines post-fault. When you have higher extreme wildfire risk conditions, you have to treat every fault as a possible wildfire ignition, and you should patrol every line within 15 minutes of the trip. And that means that you have to arrange for contractors to complete the patrols. When I look at utilities, what they should be doing is my experience when I was younger was in recovery after hurricanes on the East Coast. So after hurricanes on the East Coast or a northeaster snowstorm, we bring linemen in from everywhere. We have staging areas set up so that as soon as the outages occur, we got people out there ready to respond to them. And that's how we have to start responding to extreme wildfire risk conditions, that we stage people, and utilities do not have enough of personnel that they could stage them to go out and check every fire. One of the things they could do is they could arrange for FedEx drivers and UPS drivers and mailmen and Uber drivers to go out and patrol the line within 15 minutes of a trip out. On a distribution line, uh, you're saying, well, the high wildfire risk is going to be like maybe 7 days a year. And what's it going to cost you to get people trained to patrol your lines? Well, you're not going to train people to go out and actually do any restorations. They're just going out looking for a tree down or something like that and calling back saying they either didn't see a fire or they did see a fire. If they did see a fire, then you're going to immediately contact the local fire department and have someone go out there and work on it. So I'm thinking that if you decide you're going to use Amazon delivery drivers as your to complete your patrols, the Amazon delivery drivers are going to be familiar with the area because they're delivering packages there each and every day, right? And so you're thinking that it's going to take 4 hours to train people to what they have to do. And so you're going to have to pay something to Amazon to get the contract set in place. And you're going to pay the drivers 4 hours of overtime to get the training for what you want to do. And if there is a fire, you want to evacuate the Amazon delivery drivers out of the area too. The way I came up with thinking of this strategy is my clothes washer had an issue and the lid would pop off. It was a safety recall. It was a Samsung clothes washer. Dish, the people who supply satellite telephone service or satellite television service to your house. They called my house and they said they were coming out to do a service call. And I told them that I had Xfinity as my service provider. And they said, no, we're not coming to do that. We're coming to work on your washer. And what happened is Samsung recognized they didn't have the staff to do this in a timely manner. So they reached out to Dish, trained the Dish contractors how to do it, and they came and they did it. And Samsung got that issue behind them in no time. And that's the type of thinking we should be doing. So we're looking at immediate identification of wildfire ignition. If we wait a couple hours, if you see a smoke in the area, because we want to extinguish the fire before it spreads. And one thing I was thinking about was like recently they were talking about ghost fires in Canada. And this was publicized as if it was a big surprise. And then I thought about that a second and realized in Oregon, where I live, we had the Eagle Creek fire. This is like 5 years ago. It was a really big fire. And Eagle Creek is probably 80 miles as the crow flies from my house. But we did have ash and debris coming down on our property, which was 80 miles away. And the following spring, my wife and I went out to walk down the Eagle Creek fire, and there were a lot of stumps that were still smoking. And this was after our rainy season. Our rainy season typically starts in October, and it rains just about every day from October until April. And the rain for the whole while from October to April didn't completely extinguish the fire. And so this is the same thing that happened in Canada, and they're referring it to ghost fires that came about this spring. So I'm looking at after a wildfire occurs, you should identify and discuss effective and non-effective things you've done. So you should be getting insights into strengths and weaknesses from various perspectives. You should be getting feedback for the actions that were performed. Were they critical or were they not critical? And you document lessons learned and you try to apply them in the future. And you should be reaching out to utilities who had fires and see what information they can give you so that you can use their information. We went out on a walk down with one utility, and The third transmission pole we looked at surprised everyone because the local property owners decided that was the best place in the world to throw their leaves. So they had stacked about 6 feet of leaves at the bottom of a transmission pole. It was a wooden pole, and just thinking like, well, this is not good. But we see these kind of things happening. And so we have to spend more time looking at what we're finding out there, documenting what to look at. Because when you see it's happen one place, it probably is going to happen someplace else. It doesn't just happen at one spot and no other spots. So anyhow, what Prescient does is we do technical reports. If you have an area and you want to know the wildfire risk, we'll look at things like that. We like to write procedures for an ongoing wildfire awareness plan. Every utility should have a document that has the roles and the responsibilities for everyone that's involved in a wildfire awareness plan. The key person is the wildfire awareness manager, but the wildfire awareness manager should have an agreement with everyone, like distribution engineers. This is what they're going to do. Linemen, this is what they're going to do. And beforehand, you have everything saying that this is our agreement. This is what we're going to do. And some of the things you do is, like, if you see the risk is high, reduce your protective relay settings and block reclosing. Now we're making the assumption that you've either got fiber to the location of the relays, or you've got a wireless communication in, because somehow you have to communicate with the relays. And we're thinking that you would have a switch that you would turn on in a control center someplace, and that would broadcast all the signals you need. You change all the relays at the same time. You could be changing the relays that are associated with reclosers, the relays that are associated with circuit breakers in substations. But you should be able to just push one button, and then that changes all your settings at the same time. The wildfire awareness manager is the person who should be advising the operations, saying, operations, I've been looking at temperature, I've been looking at wind speed, I've been looking at humidity, days without rain, and by the way, I've talked to the Department of Forests, and I've talked to the Forest Service, and based on all the data I've got, today's the day that you have to go to a enhanced mode of operations. And so you should be looking. We help look at right-of-way conditions and combustible material analysis. So there's a lot of things we could do with wildfires, and we haven't crossed the hill yet where we can see the horizon in front of us. So there's a lot we can do, and we're here to help you.